This will be lesson 9, dealing with exponents. So exponents is what we use as a shortcut for repeated multiplication. We write the expression of 4 times 4 times 4 as 4 to the third. Okay, so the 4 in this case is called the base. And of course, the n, or the number exponent, would go up to the right. Okay, when we read this, we would say x to the nth power. Okay, so depending on what n is, if n is a 2, we can say squared. If it is a 3, we can say cubed. Otherwise, we say to like the 6th power or to the 11th power or something like that. So let's go through some examples here. So the first one, expanded, means it's just the repeated multiplication. Expression with the exponent, I'm going to take the base, which is this number that is multiplied, and I'm going to write the exponent as how many times it is a factor. Okay, in other words, how many times am I multiplying 11? The value is going to be 11 times 11, or 121. The base in this case would be the 2, and there are 7 2's there, so this would be read as 2 to the 7th power, which means 2 times 2 times 2 times 2 times 2 times 2, and I would multiply those all together, and I get 128. The base in this case is -5, and you should put parentheses around that. Okay, otherwise the negative looks different, and that is a factor 4 times. So it'd be -5 to the 4th power. When I multiply that out, we have to kind of pay attention to positive or negative. So if I just do 5 times 5 times 5 times 5, I get 625. But I do have to pay attention to, is that going to be a positive or a negative? So if you remember the rules of multiplication, a negative times a negative is a positive. Negative times a negative is a positive. So I end up with no negatives anymore. So it would be a positive 625. The next one, the base would be 1/4. And again, it's probably just a good idea to put those parentheses around that. And that is happening 3 times. When I multiply fractions, I multiply across the top. 1 times 1 times 1, and then 4 times 4 times 4, okay, is 64. In this case, we have 2 different bases, so I have to write them 2 different ways. One is to take the first one. It doesn't matter if I start with the 7 or the 4. So the 7 is a base, and it is twice, so that'd be 7 squared, times 4 to the third, or 4 cubed. Okay, so this is kind of a shortcut exponents for the expanded multiplication. So when I multiply all that together, I get 3,136. And you can use your calculators for that. I'm not going to ask that you do that long multiplication. Number 6, we've got 2 different bases again. So I'm going to start with the 8, just because it's the first one here. And the 8 happens 1, 2, 3, 4 times, so 8 to the 4th, times -2, and I'm going to put that in parentheses because that's what the base is, and that happens 3 times. Okay, so this would be read as 8 to the 4th times -2 cubed. Okay, so when I multiply that all together, just forget about the negatives for a minute, multiply 8 times 2 times 2, 8, 2, 8, 8. When I multiply that all together, I get 32,768. Okay, now because I have this negative base, I have to decide, is that going to be a positive answer or a negative answer? So let's take a look at the negatives here. So I have 3 negatives. Negative, negative, negative. Okay, so -2, oops. -2, -2, -2. All right, so rules of multiplication. Negative times negative is positive, so those kind of cancel each other out. There's 1 remaining negative, so that would be an answer of -32,000. 2/3, that's a bad 3. 2/3 to the 2nd times 9 to the 2nd. Okay, so if If we're multiplying 2/3 times 2/3, that's 4/9. Okay, you can kind of do some of this. 2/3 times 2/3 is 4/9 times 9 times 9. This 9 and this 9. Remember, when I'm multiplying, I can try and simplify, so this 9 and this 9 will cancel each other out, which leaves a 4 times 9, which is 36. Now, the next one is where we start getting into some algebra using variables. The variables can be bases, so in this case, the base is an a, and a is used as a factor 9 times. So if I just count these all up, I get 9 of them. So that would be read as a to the 9th. And there's no value to that until I know what a is. The base for this one, you'll notice, is xy. Okay, I'm just going to put those together. And that happens 1, 2, 3, 4, 5 times, so an exponent of 5. On the next one, you can see we've got different bases here. And again, it doesn't matter really which one you start with. If I start with the r, and I count how many r's there are. So 1, 2. Okay, so that would be r squared then. Okay, if I go with the s, 1, 2, 3, 4, 5, so s to the 5th. And then if I go to the t, 1, 2, 3, t to the 3rd, and that would be my answer. And it would be read r squared, s to the 5th, t cubed. This one I am going to start with, if I have a combination of variables and numbers, I am going to start with the number one. So in this case, I have a 9 cubed, and then k happens 1, 2, 3, 4, 5, 6 times. To find that value, I can find the value of the numerals. So 9 times 9 times 9 is 729, and then I just attach the k to the 6th. Here you can see, if I look at all of these are different bases. So the first one would be -7. And there's 2 of those. Then I have an m, 1, 2, 3 times, and an n twice. Okay, and again, when there's numbers, like in this case, the -7 squared, I can multiply that together, and I get 49. And that's going to be positive, because negative times negative will cancel each other out. And then I merely attach the other variables. 13 is a little bit different just because it's got a p minus 2, and that is considered the base, and it happens 3 times. Okay, so p minus 2 is the base, and I'm going to multiply it 3 times. This one, I'm going to start with the, you can see the, how do I know the different bases? How do I know a and b are not a base, and instead of being together? Look at the multiplication signs right here. Okay, so I've got 6 3 times, and then I've got a plus b twice. So 6 times 6 times 6, 216. And then I have a plus b as another base that is going to be squared.